Hi everyone, I'm Pat Coughlin, and my research project is about simulator sickness and the effect it has on simulation-based learning experiences. Simulation-based learning is one of the most common negative side effects from using simulators. It's a lot like regular motion sickness, but specifically from overuse of technology or getting a feeling that you're moving when you're actually stationary. You might experience this feeling in virtual reality, playing a video game, watching a 3D movie, anything like that really. So the two forms of research I've proposed are a survey and an experiment. The first milestone deliverable was survey data, and this milestone will be a showcase of my experiment and results. The purpose of the experiment is to prove direct causation between motion sickness and the efficacy of simulator-based learning. I wanted to determine a baseline metric, induce motion sickness, and then retest for the experimental metric. So I have the procedure listed in the document, but uh, and this has all the specifics really, but to emulate performance in a simulator, the test metric is a mouse accuracy test. The website linked is a kind of game where you need to click targets as they pop up, but I specify that it needs to be on the hardest settings, and then after the game is over, it tells you how many targets you hit, how many you missed, what your clicking speed was. I can pull it up for a quick demonstration. So it kind of looks like this. And this is meant to simulate how uh, one would be tested in a simulator, how your performance. This is the performance metric, so you can measure whether you're doing better or worse. So we would do this before to establish a baseline metric, and then again afterwards to establish an experimental metric, and the results are pretty easy to read. So then to induce simulator sickness, my research showed that one of the closest experiences to VR is first-person video games. So I picked Skyrim since it's common, and it's actually notorious for causing motion sickness in first person. I set two goals to complete, and this would make the participant engage for about 30 to 60 minutes, and I specify some additional settings like use headphones, sit close to the monitor, turn mouse sensitivity to high. And then I also ported a copy of the simulator sickness questionnaire to an Excel sheet to attempt to quantify the dosage of simulator sickness, because this is currently the industry standard. But the overall flow of the procedure, like I said, is they would complete the baseline tests, then they would dose simulator sickness, and record all these results. Then they would complete the simulator sickness questionnaire to see essentially how much sickness they have, and then finally to take the mouse accuracy test again. So, and to ensure no deviant behavior from one bad test, I'd asked each of the participants to perform this test 3 times over 3 days. This would provide data on whether a subject gets used to the conditions of the simulator and can perform better over time. I had 6 participants conduct the experiment, all people that I know from daily life, and since they'd each performed the experiment 3 times, I got 18 data points. All participants had the materials needed to complete the experiment. That's part of the reason why I chose them, uh, such as desktop PCs, headphones, and Skyrim downloaded and playable. I sent each of them the formal procedure that I just showed, and as well as this Excel sheet, which has 2 templates that they would fill out and then send back. This one here is the template for the simulator sickness questionnaire, and it has a list of symptoms and instructions to say to fill it out with values 0, 1, 2, or 3, meaning that the symptom has a severity of none, slight, moderate, or severe. This questionnaire and calculations are from one of the other sources in my project proposal, and each of these symptoms is maps to a subscore for either nausea, oculomotor, or disorientation, and each of them has associated multipliers to add weights. The total score is then, again, a weighted sum of these 3 fields. So, for example, if I determine that I have a moderate headache and moderate nausea. These would be the associated scores, and then a total score of about 232, which is actually in the low range because I only filled out 2 symptoms. So then I have the next template this is the one that's meant to track scores for the mouse accuracy game. The instructions provide the website and the required settings. And then after the game is done, the subject would list the results here, and I have fields for both before and after for days 1, day 2, day 3. Then I have 6 sets of results from each of the people that I asked to participate. And you can see they're all pretty varied, but they were probably hitting about average performance and everything. And the method of inducing motion sickness actually seems successful because I got positive results in every test. Everyone said they'd at least gotten like a headache or some dizziness consistently. And then after I looked at all of the results, I took some deltas for how they performed on the mouse test before and after simulator sickness, and I threw them into scatter plots. The chart on the left is the change in the number of click hits versus the simulator sickness questionnaire score, and I was looking to see if the subject clicked less with higher quantified simulator sickness. The trend line is going down slightly, but not enough that I would draw conclusions, and there's a lot of variance around the trend line, signified by a low R-squared value of 0.03 roughly. But we can see that almost all of these deltas, which are before number of clicks minus after number of clicks, they're all almost all negative, meaning that we do see decreased performance with any simulator sickness, or that they slowed down because of fatigue, which also counts. But we don't see that the worse simulator sickness gets, the worse they perform. That would be a much steeper trend line. The chart on the right is the change in the number of misses versus sickness score. This one has an upward trend, signifying the sloppiness gets worse with higher simulator sickness, and it has much less variance because this R-squared value is about 0.124. And then the last part of this deliverable is the t-test that I calculated to draw conclusions about the null and experimental hypotheses. I had decided to split this into the same 2 metrics, the number of clicks and the number of misses. Here I have number of clicks and number of misses, since those 2 metrics seem to indicate 2 different things, namely speed and accuracy. The t-test to determine if the differences, the t-test is meant to determine if the differences between before and after results deviate significantly from 0, meaning that the experiment did produce some sort of change. The alpha values for both calculations are set to standard 0.05, and if it passes the test, that means we're 95% confident the results are statistically significant. The first calculation for if the number of hits changed differently before and after the test, we have a very low p-value of 3.32 times 10 to the minus 7. So since that is less than the alpha value of 0.05, we reject the null hypothesis. And that's actually good for the results, because that means we are leaning to accept the experimental hypothesis, which is that simulator sickness does affect performance. So then for the second calculation, this is the change in the number of misses. The p-value is 0.213, which is larger than 0.05, so we do not reject the null hypothesis in this case. So overall, our conclusions are that simulator sickness affects the speed at which you can work, but it doesn't necessarily affect the sloppiness. However, because of the increasing trend line in the scatter plot that we created, we would say that it affects sloppiness only if you have a higher severity of symptoms. So I will clean all of this up and put it in the final deliverable.